Today we are starting Unit 3 and our 3.1 notes. It's graphing systems of equations. So it looks like this. Our goal today is to solve systems of equations by graphing. So a system of equations that's just multiple equations. Okay, that's all it is multiple equations. And the solution to a system has to be a solution to all of the equations. Right now, we're only going to be using two equations, so a solution to both. However, in the future, we'll do more than two. So in that case, it will be all. So a solution to either both or all equations. Now, I just want to show you a general idea of what this is going to look like. You'll want to use a straight edge when you draw these, but it does not have to look exactly like mine. But I'm going to draw, for the very first one, I'm going to draw two parallel lines. Now, parallel lines have what kind of slopes? The same. Yes, they have to have the same slope. So if I want my first line to have a slope of like 1/4, then I need both of my lines to have a slope of 1/4. So I'm going to draw two parallel lines. Just two lines that have the same slope would be parallel. So that looks good enough. Maybe I'll make them two different colors so we can obviously see what we're talking about here. So that pink line and the blue line are parallel. They both have a slope of 1/4. So far, so good? So they're parallel. You could even mark them parallel using the symbols that you learned last year in geometry. Okay. How many solutions will this system have? How many times are those lines going to intersect? Zero, never. They never intersect. So there are 0 solutions. We call this an inconsistent system. Okay? And you'll see that the characteristics are that the lines are either parallel, which means they have the same slope. Okay. The next one that I'm going to draw are going to be two lines that intersect. And again, you don't have to make this exactly like mine, as long as you can see that you'll have two lines that intersect. That would be fine. And you can see where they intersect at. So two lines, they don't have the same slope. In this case, one's positive, one's negative. They could both be positive, though. That doesn't matter. Okay? How many times do these two lines intersect? 1. So we are going to have one solution. Okay. We call this an independent system. Okay. Independent. Independent means one, so one answer. It's one answer there. The characteristics, they have different slopes. They don't have the same slope anymore. Now, you guys learned that we can represent an equation many different ways, right? We could have one graph and we can write that equation in standard form or slope-intercept form or point-slope form. Any of those forms would work. Now, we might be given two equations and they might look different, and when we go to graph them, here's the first one, and then you go and graph the second one, and whoa, we just overlapped our two lines. How many times do these two lines intersect? Infinitely many. Okay, we call this a dependent system. And the characteristics are they have to have the same slope, and they also are going to have the same y-intercept. Because they're going to look like the same equation if you change them both to slope-intercept form, which is usually how we graph. Okay? They have to have the same slope. They have to be the same line. So the same slope, the same y-intercept. All right, we have a couple examples. The first one is to solve the system by graphing. Check the answers and state whether each system is independent, dependent, or inconsistent. So, we need to graph both of these. Can we graph 3x plus y equals 5? Manipulate it a little bit, right? So let's manipulate this. How could we manipulate this first equation so that it would be easier to graph? Subtract the 3x. We get y equals negative 3x plus 5. Can we graph that? Yes, that's much easier to graph. So, our y-intercept is at 0, 5, and my slope tells me to go down 3, right 1. Cool. I have as many points that will fit, and then what I'm going to do, it's important that you use your straight edge, use the edge of your binder or something to make sure you can connect all those points with a straight line. If you can't, if you're trying to do it freehand, that's not going to give you the hint when you accidentally mark one of your points incorrectly. Okay, so it's important that you do use a straight edge and make sure your straight edge goes through all the points possible that you put on there. All right, so the next one is this x minus y equals 7. Can I graph that from the way that that equation looks? We could. You could find the x and the y intercepts and then go from there. That one's actually easy because x times, what would I plug in for x? I plug in 0 for y. What can I plug in for x to get to 7? X equals 7. What did x have to be? 7. If I plug in 0 for x, negative of y is equal to 7. So I'm going to divide by negative 1 on both sides. What's y have to be? Negative 7. So you could do it like this. Okay, we'll do it both ways. How could you change it to be a little bit easier to graph, though, if you wanted to put it in a different form? Subtract x. We're going to have negative y equals negative x plus 7. Then what? Divide everything by negative 1. Y equals, so that turns to positive, that turns to positive, that turns to negative. Okay, so I go to 0, negative 7. I graph it, and my slope is up 1, right 1. Ooh, I can see the intersection. Connect it with my straight edge. Now, this is where you could probably check at that point. 7, 0, is that one of the points plotted? Yep. 0, negative 7, is that plotted? Yep, so I can see my intercepts. So you could have done it that way and connected it. And where's the intersection now? What is this point right here where they intersect? What's the x coordinate and then what's the y coordinate? 3 comma negative 4. So your solution here is 3 comma negative 4. Okay? And then what type is this? Is this independent, dependent, or inconsistent? Independent. So we have to make sure we specify that as well. On your quiz this week, you will have to be able to identify it as independent, dependent, and inconsistent. If you can at least do that, that's a point that you automatically get on all of your questions. Okay? You have to be able to identify those. So that's the independent. All right, let's flip it over. And the next one says, without graphing, classify as independent, dependent, or inconsistent. What's the main thing that we're going to look for if we're trying to figure out the difference between inconsistent, independent, or dependent? What's the main thing that we need in order to identify those? The slopes. We need to know, do they have the same slopes? Do they have different slopes? Or do they have the same slope and the same y-intercept? So how do you guys want to go about? No, we're not going to do any multiplying. You're thinking about when we're solving. We're not solving. We just want to see we have to picture what this graph looks like without actually graphing it. How did we graph it before? What did we need to do to the equations? Put them in slope-intercept form. So just change both the equations to slope-intercept form, and then we'll look and see, do they have the same slope? Do they have different slopes? If they have the same slope, do they also have the same y-intercept? And if we put them in y equals mx plus b form, we can see right there the slope and the y-intercept. So we'll be able to identify that. So we'll take this first equation first. And how do we get y by itself? Subtract the 3x. So we're going to have negative 6y equals negative 3x plus 6. And then what do? Divide everything by negative 6. So we get y equals, that becomes 1/2, that reduces, x minus 1. So this is equation 1. If you want to come write it back up here so that you know y equals 1/2 x minus 1. But that's what that one went to. That's fine.
6 minus 6. Oh,
Divided
no,
by negative 6.
Okay, yeah.
Okay. Then we're going to do the same thing on the second equation. We're going to manipulate this one to get y by itself. So what's the first thing we're going to do when we have to get y by itself? Subtract the 2x. So we're at negative 4x equals negative 2x plus 4. And then what? Divide by negative 4. And we get y equals 1/2 x minus 1. So this one turns into y equals 1/2 x minus 1. What do you notice about those two equations? Same slope, same y-intercept. So what type of system do we have if you guys can't even see what I'm pointing to. Okay, if they have the same slope, same y-intercept, that means it's a dependent system. So we're going to write in here dependent. Does that make sense? Okay, let's try the next one. We'll take this first one. 6x plus 8y equals negative 16. What's the first thing you're going to do? Subtract the 6x. So 8y equals negative 6x minus 16. And then what? Divide everything by 8. Y equals, that becomes negative 3/4 x minus 2. I like to write it right there so I know exactly what I did and what it became. All right, the second equation, what should I do first? Subtract the 3x, so I have 4y equals negative 3x plus 12, and then what? Divide everything by 4. Y equals negative 3/4 x plus 3. Okay, what do you notice about these two equations? Same slope, different y-intercept. So these are going to be parallel lines. Okay, you can see they're going to run alongside each other, but they don't intersect, right? Because your y-intercepts are different. All right, so what kind of system is it when you have parallel lines? Inconsistent. So our answer here is inconsistent. You guys are doing good. Give me a 1 through 5. I see what you're doing. I think I can handle these ones on my own. Look at all those 5s. See, I tell you, I give you guys one linear equation, you're like, Mrs. Fox, this is the hardest thing I've ever done in my life. I give you 2, you're like, this is the easiest thing in my entire life. I don't get it. All right. Maybe it's just because we've been practicing so much with linear. The first one's already in a nice form, so I think I'll leave this one alone. Is that okay? All right, so the second one, let's manipulate this one a little bit. What am I going to do to that second one? Okay, so y equals 4x plus 1. Should I do anything else? Nope. What do you notice about these two? The slopes are different. Don't get confused if you have opposite slopes. Those are still different slopes. If they're opposite, those are 2 different values. They're 2 different numbers. This one's a negative 4x, that's a positive 4x. They have different slopes. So what kind of system? Independent. All right, that's that type of problem. Example 3 says to solve the equation and check the solution, show work for full credit. So this is just review. Okay, so for A, I am going to solve for a variable. So I'm solving for m. There's lots of m's here. So I need to get m's all together and in one spot so I can solve and figure out what the value of m is. So combine like terms on the left. What do you get? Negative 2m equals 12m minus 8. What should I do next? Subtract 12m on both sides. You can do that. Some people would have added 2m to both sides, which would also work. Doesn't matter. So you have negative 14m on the left equals negative 8 on the right. Then what do? Divide by negative 14. We're going to get m is equal to, negative divided by negative is a positive. 8 over 14 reduces, both divide by 2, so 4 over 7. So m is 4/7. Okay. If you plug that back in, trying to not get it, there we go. Okay, I can put, okay, so 4 over 7 is that value. I'm going to do that. Negative 3 times answer plus answer. That's that value. Okay. 12 times, I'll just type it in this time, 4 over 7 minus 8 is that exact same value. So I must have done it right because that's equal to that. So you can plug it in to check and make sure that that solution is the solution to that equation. When you plug it back in, the equation is true. Because of that, you know that that's the solution. Okay. Now, I can have that as a decimal when I check my answer because I'm not writing that anywhere on my paper. Right? That's not an answer. That's not my final answer. My final answer was given as a fraction. We don't put decimals down. Okay? And some people are still struggling with that. They're losing points because they're giving me a rounded answer. If you tell me 4/7, you're going to tell me 0.57, which is not the solution. That will not give you the solution. 0.57 is not the solution because it's not exact. You rounded it. That is approximate. Okay? All right. So for B, what are we going to do? Solve for A. What do you guys notice this one has? Fractions. Do you guys like fractions? Not usually. What can you do to get rid of them? Multiply by that denominator. So what's the denominator here? 3. So you can multiply every single term by 3. Okay, when you do that, 3 times A divided by 3. Well, when you multiply by 3 and divide by 3, that turns into 1, right? 3 over 3 is just 1, so that's going to be A. Minus 3 times 6 is 18 equals 3A plus 3. So far, so good? All right, well, that's a lot easier. Make sure that looks like a subtraction sign there. That looks a lot easier than dealing with that fraction. So what should I do now? Do what? Add 18? We can add 18, sure. Okay. So we have a equals 3a plus 21. Okay, then what? Subtract 3a. That'll go away over there. Negative 2a equals 21. Then what? Divide by negative 2. Divide by negative 2. A equals negative 21 halves. Ooh. That's it. Okay, so up until lunch, so you guys have about a half hour. You guys can work on that assignment. Okay, the 3.1 assignment. Now, notice that I did not already draw in scales. So you're going to have to kind of visualize what will this graph look like. Because if you don't do proper scales, you won't see where the two lines intersect. And you have to see where they intersect in order to find the solution. Okay, so on each of these, you should write your solution down, which has to be a point. You have to write your solution as a point. And then the type of system. So you have to tell me, is it independent, dependent, or inconsistent? Okay. And so what I would kind of do here is I would kind of sketch my graph of what it was going to look like. This is going to have a positive slope, and it intersects below the origin. This one has a negative slope, and it's going to intersect above. So it's going to look something like this. So I know to the right of the y-axis, to the right of my y-axis is where they're going to intersect. Okay, that's where they're heading towards each other. So if you kind of can do a sketch, I know that this is going to be here at 7, and this here is at negative 2. They're going to intersect somewhere between 7 and negative 2, and to the right of my y-axis. So when I go to draw in my axes here, I can put my y-axis way over here, because I don't need to draw anything to the left of it. So maybe I would draw my y-axis here. And then I need to make sure I have at least negative 2 on there, and I want to go up to 7. So maybe just kind of figure out, okay, if I do it here, I'll be good. And then I can go by ones. 1, 2, 4. Does that make sense, how you should be drawing in those axes? Okay, so kind of think about where you want those axes to be. Because then here, this point intersects up there at positive 7. This one's going to be down here at negative 2. And then we can draw, and we'll be able to figure out where they intersect at. Okay? But just kind of, if you draw a little sketch, it'll kind of help you. Where should you put your axes, and what should you make your scales?